Assalamu alaikum. Physical Geology, Chapter 12, Mass Wasting, presented by Khalid Lamrouni, PhD in Geology from Texas A&M University, and Khalid Lamrouni, a staff member at the Department of Earth Sciences, Yunus University, Benghazi, Barga State, or Cyrenaica State. References used in this talk, Essentials of Geology. This is the Department of Earth Sciences, Yunus University, and this is the main entrance of Lutgens University. This is the Prince Idris, Prince of Cyrenaica State, and the founder of Yunus University. And here's the flag of Cyrenaica State behind the Prince Idris. Benghazi is the capital of Cyrenaica State. Omar al-Mukhtar is the chief commander of Senussi army. And this is the map of Barga State or Cyrenaica State. Outlines of this talk: the importance of mass wasting, landslides as geological hazards, role of mass wasting in landform development, slopes change through time, controls and triggers of mass wasting, role of water, oversteepen slopes, removal of vegetation, earthquakes as triggers, landslides without triggers. And then we'll go through angle of repose, classification of mass wasting process based on type of material, type of motion, and rate of movement. The importance of mass wasting. Landslides as geological hazards. A landslide is a sudden event in which large quantities of rock moved downhill. Mass wasting refers to the downslope movement of rock, regolith, and soil under the direct influence of gravity. So gravity is the main force, the transportation force agent. The role of mass wasting in landform development. Geological process that often follows weathering. Sediment is ultimately transported to the sea. The combined effects of mass wasting and running water produce stream valleys. Yes. Because in sediments transported by the gravity, the water will pick it up and transport it to the ocean, so that this way it creates conduits or valleys down the road. Slopes change through time. Most rapid and spectacular mass wasting events occur in areas of rugged, geologically young mountains. Mass wasting and erosion processes slowly change these rugged mountains to more sudden terrain. So here, for example, mass wasting in running water created the Grand Canyon in Colorado. Controls and triggers of mass wasting. The role of water over steepened slopes, removal of vegetation, earthquakes as triggers, and landslide without triggers. So role of water. When sediment pores filled with water, cohesion among particles are destroyed. And water can lubricate materials. Water adds weight to a mass of material. So particles, when they are saturated with water, they lose the cohesion and lose the cohesion force, and then became loose. And that will help, the gravity to transport them. Over steepened slope and consolidated granular particles assume a stable slope at the angle of repose. So angle of repose, the larger the grains, the larger the angle, or the bigger the angle of repose. Angle of repose different for various materials, correct. Over steepened slopes are unstable and can trigger mass wasting. Natural processes such as stream cuts oversteepen a slope. Removal of vegetation. Plants bind soil and regolith together. in addition to shielding the soil surface from raindrop impacts. Vegetation is removed by forest fire or by human. Timber farming development cause problems of mass wasting. Earthquakes as triggers. Earthquakes can dislodge rocks and consolidate materials. And examples in California and China. Liquefaction. During periods of ground shaking, earthquakes, water saturated surface materials behave as fluid like masses that flow. Landslides without trigger. Slope material weakened over time can happen. Some landslides are random, unpredictable events. So here we have heavy rain triggered debris flow. So this is the valley, and the debris just came down to the town and started covering houses due to the heavy rain. Here on the stable slopes, so this is oversteeping slope, and this is loose sediments, and the house built over on these loose sediments. And when rain comes, these surfaces will be saturated and start sliding down under the weight of the gravity. Earthquakes. Earthquakes can cause mass wasting. And saturation reduces the friction. So here we have sandy grains, dry, no water, bound mainly by the friction with one another. They have contact. If we add some water, small amounts of water, increase the cohesion among grains. So grains can still contact each other and still coherent. So we can build up this castle using them. But if we added more water, the grains will lose the contact and stay far away from each other. So saturation reduces friction and causes the sand to flow, and all this castle will fall down because it's wet now. Too much water added. Mass wasting. Definition: mass wasting is the downslope movement of rock, regolith, and soil under the direct influence of gravity. Weathering breaks up rock, gravity pulls the material to the lower elevations. Streams carry it away to oceans. Gravity is the controlling force of mass wasting. And water is an important factor in bringing about the downslope movement. Oversteepening of slopes is another cause of many mass wasting. Now, angle of repose is the steepest angle at which material remains stable. According to the size and shape of the particles, the angle varies from 25 to 40 degrees. So, for example, if we looked at this shape, we find there is an angle of repose. If these material coarser, the angle of repose will be bigger. If these materials are finer in grain size, the angle of repose will be smaller. So each grain size has different angle of repose. Classification of mass wasting processes. We have three types of classification based on type of material, based on type of motion, based on rate of motion. So if we're going through the first type, which is type of material, classification depends on whether the descending mass began as unconsolidated material or as bedrock. So what we have through in this, debris, mud, or earth are used in the description of soil and regolith dominated the descending mass. So all of this unconsolidated. Say debris flow, mud flow, earth flow, that means unconsolidated material. Rock is used when mass of bedrock breaks loose and moves down slope, consolidated. So this second type, consolidated. So consolidated would be described as rock flow, and unconsolidated as debris flow, mud flow, or earth flow. Types of motion, the way in which material moves is important. The motion is called a flow, a slide, a fall. A fall is a free fall of detached pieces of any size. Many falls result from freeze and thaw, especially in the polar regions and mountains. Many, number two, slides. Many mass wasting processes are called slides. They occur when material remains coherent and moves along a well-defined surface. So fall, you don't need defined surface, but sliding, you need coherent material and a defined surface. Sometimes the word slide is used as a synonym for the word landslide. Flow occurs when material moves down slope. So here we need slope as a viscous liquid in the material in a viscous condition. They move as loops or tongues. The third classification, rate of movement. We have rapid movement and slow movement. But let's see some information here. The speed of rock avalanches is about 200 kilometers per hour. That's so fast. The term creep describes the movement of the slow particles. It's usually measured in millimeters or centimeters per year. So let's go. It's just a contrast between high-speed avalanches and very low-speed creeps. Two types of movements. Rapid movements, we have landslide, which includes slumps and rock slide, mud flow, earth flow. Those are very fast. And slow movement, creep, and solifluction. So landslide may be divided into two basic types, slumps and rock slides. Slumps refer to, or slump refers to the downward slippage or slipping of a mass rock or unconsolidated material, moving as a unit along a curved surface. So we need a curved surface for the slump. This is the main condition. A slump occurs when a slope has been oversteepened. Rock slide. It occurs when blocks of bedrocks break loose and slides downward. So here we need coherent material to have a rock slide. Rock slides are very fast and destructive. Earthquakes trigger rock slides. The slide occur when the tilted and undercut sandstone bed could no longer maintain its position on top of the saturated bed of clay. Yeah, so when we have two beds, clay and sandstone above clay or shale, when the clay or shale is very saturated and undercut, the sandstone will start sliding. Now mud flow is the flowage of debris containing a large amount of water. So we need water here with the mud. They are commonplace in canyons, and mud flows are common in volcanic regions called lahar. Earth flow, it occurs on hillsides in humid areas as a result of excessive rainfall. So mud flow confined within the canyon or valley. Earth flow along the hillsides, not inside the valley itself, but on the hillsides of the valley. Slow movements, one creep, takes place on gentle slopes. They are widespread. It's gradual downhill movement of soil and rivulet. It's caused by freezing and thawing Soliflaction is the downslope movement of waterlogged soils, promoted by a dense clay hardpan or impermeable bedrock layer, common in regions underlain by permafrost. Permafrost, that's the, the layer or the earth is frozen for the whole year. We call it permafrost. So slump, we have very well defined surface, rupture surface, and sediments just flow along or sliding along the surface. And here we have earth flow along the side. Or the front of the lobe of the slump. Here we have slump, and you see the rupture surface. It's very well defined in California. Rock slide, pieces of rock detached and sliding along the defined surface, called surface of rupture. Debris flow, flowing along or confined along valleys. And if there's a lot of water, in this, it's mud and water. A lot of water, we can't call it mud of flow. Lahar, it's a volcanic mud of flow. Earth of flow, it happens on the sides, the hill sides of the valley. In creep, so here we have these grains during freezing and thawing, when it's expansion caused by freezing and then contraction caused by thawing. Freeze, thaw, freeze, thaw. It goes down the hill, down the slope. It's very slow, and this is the regolith layer. Here's soliflaction. We have a very frozen or permafrost layer, and the top part, active layer, goes through fall in summer, freezing in winter. So that creates the soliflaction undulated surface as you see it here. And this is in Arctic Circle in Alaska. Soliflaction loops. Permafrost thaw. So this house built when there's a source of heat here, chimney. The permafrost layer started, the top part of it started. The thawing process, and then the water will be the or the the pores will be compacted. The layer will be compacted, and this will cause the sinking of the house. And this is a real example for the heating of the permafrost layer. And by this, we came to the take-home message, the end of this lecture. So, take-home message is the importance of the mass wasting, landslide, and as geological hazards, the role of mass wasting in form development, slopes change through time, and then controls and triggers of mass wasting, water over steep slopes, vegetation removal, earthquakes, and sometimes without any trigger, landslides. And then we looked at the angle of repose, the steepest angle at which a grain stays stable, and then a classification of mass wasting process depends on type of material, type of motion, and rate of motion. And by this, we got to the end of this talk, and we'll take 3 minutes listening to the national anthem of Cyrenaica State.
أشعاع نير أما السواد مذكر ولطالما نفع الذكير يحيى الأمير يحيى الأمير إدريس أنت أميرنا إنا بنوك ففق بنا لبيك يا رمز المنى في أي ناحية تشير يحيى الأمير يحيى الأمير. نحن الشباب الناهضون وإلى المفاخر راكضون بالأمس جاف رابضون واليوم قد حان المسير يحيى الأمير يحيى الأمير. العلم نور حياتنا والدين خير هداتنا والصبر سور صفاتنا والله مولانا النصير يحيى الأمير يحيى الأمير.
Thank you very much.